Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream unless we are on RSI break, which we are right now. So we're just doing Q&As because the right hand is fine, and so it can draw. Got a question from Andrew JDR on the Twitch chat. Wanted to know about SGX, which is Intel's new thing in x64 processors coming down the road, which basically is going to be like DRM, squared, or maybe even 2 to the DRM power. So yeah, if you're one of those people out there who likes being able to control your computing devices, those days are probably pretty numbered. And I suppose on the slight positive side, if you're somebody who is worried about your game being pirated, well, that might never happen again after this, so there's that too. But we'll save the philosophical part of it for a little bit later, and I'll just talk about the general concept here, because this is actually not something new. This is actually something that other computer systems, I want to say that Silicon Graphics or Sun, I don't remember who, one of those two have had this a long time ago, actually. And so this is actually not particularly new. Although SGX is a whole family of things, and some of things in that family sound new to me. I had not heard of them before. So the DRM part of it is not new, but the other parts are, I don't know if they're new because I don't study hardware that often, but they definitely were new to me. Like, I hadn't seen it before. For whatever that's worth. All right, so how do you make Unbreakable DRM? Right, how do you do that? Well, the answer is that it really doesn't take much. So the way things currently work on a CPU, right, is it looks something like this. I have a CPU, here it is, right, and Mr. CPU is connected to a network card, right, some kind of a thing that goes out to the internet, and that goes out to the internet and it talks to, let's say, Valve, right? And Valve sends back through this internet card something that the CPU then probably has to interface with, but eventually it writes it out to your hard drive, okay? And it is the executable, right? It's the game, writes the game. It's got the exe, it's got the data, all the stuff is here on the hard drive, okay? And that's just how everything works right now, right? You go out, you buy something on Steam, the network card talks to Valve, it downloads a bunch of stuff, it writes it to the hard drive, and now your CPU goes and it plays this, right? And so let's just put ourselves in Valve's position. Again, I'm not trying to make a philosophical judgment here. Let's just assume that we think that DRM is a good idea, all right? And certainly, Valve takes a neutral stance on this, which I commend them for. They do not force DRM on their customers. So basically, it's the publisher's decision on, like, when you're on Steam, the publisher decides whether something is DRM'd or not. So Valve, to their credit, does not force DRM on anybody, right? It's like, if the publisher wants to do it, they do it. If they don't, they don't. But point being, let's say you're Valve and people, are like, hey, excuse me, this is, you know what, I'm going to draw a publisher here. So they're going to be like big and fat, and they have like a tie on, like a pinstripe suit, right? And they're probably on just like tons of money. There's just probably this like huge pile of money. Like, these are little sacks of dollars here, right? So this is like Mr. Electronic Arts or whatever. And he's like, excuse me, Mr. Valve, but people are pirating my game, and I don't like it, right? This hair is probably slicked back here, I'm guessing, and he's probably smoking a big old fat cigar that the cigar probably cost more than most people's computers. So this is probably like a $5,000 cigar, and he's like, excuse me, but, people are pirating our game, you need to do something about this, right? So what can Valve do in this scenario? So what Valve can do in this scenario, and what I have done, and to be fair, I haven't looked at Valve's DRM, but so I'm making this up. Here's one example of what they could do, and probably roughly what they did. What they can do is say, well, okay, every instance of this, I know that, this CPU and this NIC and this hard drive are in a user's machine, and I know that user has a Steam ID, right? So I know that when a user buys a game, I know who that is. And when they talk to me, they have to tell me who that is because I won't give them the game unless they're logged on, right? You can't just ask Valve for a game and it gives it to you. You have to prove that you're a customer, so you have to have credentials and all that stuff, right? So they know the Steam ID, and the Steam ID goes across the network. So what Valve could do, for example, if they want to, is before sending this back to you, they could make some changes to the game package itself such that your Steam ID is inexorably linked to it, right? So there could be some modifications to this data. This data here could have your Steam ID baked into it in some kind of way, right? Like, for example, let's say I run some kind of encryption on it where I use the Steam ID as an encryption key or something, right? So now, whenever I go to launch this game, the Steam launcher tries to launch the game, it has to use whatever the Steam ID is or something like this to decrypt the game, right? Or maybe something else, maybe it's not the Steam ID, maybe it's like a key that comes back from Valve and then it decrypts the game and runs it, right? Something like that. Makes sense, right? This is reasonable DRM. It probably stops a number of people, but obviously if you are a pirate, or I shouldn't say pirate, if you're a cracker, someone who's going to try and crack this to produce a version of the game that can be distributed external to Steam and without verification, well, it's not impossible for you to do that. Because when this comes back over the NIC, it gets written to the hard drive, you can now observe this. And furthermore, when the game is run, you can observe the game running, right? So you can figure out, especially by looking at two different people's installs and looking at the difference between the two packages, for example, you can probably determine after some amount of work what the changes have been to this, and you can undo them, right? You can turn it back into an executable that does not depend in this way on something unique to the user, right? So now, instead of something which has to be run under the guise of a particular user's Steam ID because the game is actively trying to like decrypt itself using that as a key, or something's happening and they're using that as a key, and if you don't have that key, it won't work, right? They can just turn it into so that it always runs with that key and just knows that, or it's been decrypted and they just distribute the decrypted version, right? So you can understand that there's many ways in which this might, depending on exactly how it was done, because they can watch it all happen, and because they can then undo it, because whatever the CPU was doing to run it in the first place, they can obviously undo, right? It's no problem. Okay. So how do we make something that does not have that problem, right? How do we make something where it's simply not possible for anyone to ever break the DRM, short of, say, the NSA or something? So how do we do that? Well, what we do is we modify this diagram a little bit. So before we had CPU, NIC, and hard drive, right? And we're still going to have those. But now we're going to add something very specific. Because here, remember, this was our weakness. The Steam ID, or whatever, whatever is based on this login credential thing, whatever Valve sent us back, whether it's a Steam ID or a decryption key or whatever it is in the system and visible to the attacker. And as long as that's true, they're always going to be able to break the DRM. Because as long as they can view what that is, there's nothing you're going to be able to do. They'll eventually, if they really want to, crack it. And you can make it harder and harder and harder for them to untangle all the stuff that you did based on this. But if they are willing to spend enough time, they will always be able to do it. Okay? So what's the problem? What's the problem? The problem is that, right? So how do we fix it? Fix it. Well, what we do is we put it inside the CPU, right? So what we do now is, instead of making that key, instead of making, this is effectively our key that the whole DRM is based on, instead of making that key be something that's out in the open, we just bake the key directly into the CPU. Okay? So the key's inside the CPU. Still got the NIC, still got the hard drive, right? So now what happens? Well, what we do is we use, for example, let's say we use something like RSA encryption, right? Some kind of public key encryption, okay? And for those of you who don't know what public key encryption is encryption that has two different keys. It has a public key and a private key, and these things go together. And the idea is that the public key is something that everyone can observe, and stealing that key or that key being exposed is totally fine. It's expected that everyone in the whole world could be given this key, and that the private key, on the other hand, will be kept secret. And what public key encryption allows you to do is to use a public key to encrypt a message. Okay? So basically, if I have some message, if I have a secret, I can apply encryption to it using the public key that produces an encrypted secret that only someone with the private key can decrypt. So anyone can encrypt. Anyone can turn something into an encrypted secret with the public key, but only the person with the private key can decrypt it. Nobody else ever can. The only way they can is by cracking the actual encryption, which, as far as we know to this day, mathematically speaking, requires actually doing brute forcing with like a giant, computer array. And granted, depending on the particular public key scheme, like RSA, certain things have been cracked and blah, 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 blah. So you probably would not pick RSA, but point being, you'd pick some secure public key scheme, elliptical curve cryptography, for example, blah, blah, blah. Okay, so do you see where this is going? Inside the CPU, we store the private key. And it is baked into the CPU such that nobody, literally nobody, can access it. It's built into the circuitry of the CPU, and the only way you will ever get it out is by doing some kind of crazy, crazy hardware hacking on that CPU, which I guarantee you, Intel's fab technology is very, 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 very good. So I strongly suspect that this is something that only like a state actor probably will ever do, although, who knows. Never count out Europe. Sometimes like hackers in Europe have elite skills and crazy hardware. But point being, probably not going to happen, right? Because it is baked into the hardware. Okay, so since we have this baked into the hardware, okay, we've got the CPU, it's baked in the hardware, the private key, and then it also has its corresponding public key, which anyone can see. Okay, that's actually just exposed in the system. So now what do we do? Well, now what we do is we say, okay, we're in our situation where we're going to buy a game. We say, hey, Valve, we bought this game. Please give me the game. They say, no problem. Give me your public key. Your public key goes across the network. Valve takes it. They encrypt the entire package with that public key. They send it back, right? And here we write into our hard drive. We write the encrypted game. Now remember, nobody can possibly decrypt this game. It's not possible to decrypt it at all unless you have the private key. So the only thing that could possibly decrypt the game is the CPU right now. So then you use Intel's SGX instruction set to say, I would like to load and execute an encrypted package, please. And it uses the private key that's directly in the CPU to decrypt the game code and its accompanying data, if you wish. And the CPU is set up such that no one can ever observe it. That's what the SGX extensions actually allow you to do. All of the memory is protected. No one can actually access it. So it is completely isolated. So literally, this creates, unbreakable DRM in a very specific sense, right? Unbreakable, you always have to quantify because, is it really unbreakable? Well, nothing's probably actually unbreakable, right? But what it means is that it is not software breakable, meaning nobody will ever be able to break it in software like they do now. What you would have to do is actually reverse engineer a specific CPU with the game on it, and then you would do this process, right? And that would be a thing that I believe would require hardware and like a lab that's so expensive that almost nobody has access to it. So will the NSA be able to crack Steam games? Yes. Will China be able to crack them? Their equivalent of that? Yes. Because I guarantee you they've got such hardware and are probably using it. Will hacksaws who post to Pirate Bay? Probably not. Right? So there you go. That's how that works. and a C, you could just give them another public key that you have the private key for. So that part of the process obviously is, it's, so to use a build term, it's turtles, you know, all the way down at that point, right? So you have to imagine if you really want to make Unbreakable DRM, you do this for everything. So the Valve executable that gets installed is also only installable on, you know, the Windows machine, which is also only installable on the hardware, right? It's like it's a trusted platform on the whole stack, if that makes sense. So presumably, if you really want to actually do the whole thing, then all the code has to be trusted and signed. And, you know, will they do it? I don't know. You know, they may not want to. Maybe Valve doesn't want to do this, and or who knows who else, right? So I don't know, you know, whether they will, whether they won't. It's already the case, right, that Windows kind of has a little bit of this stuff built into it that used the Trusted Platform module. And so once they have this, presumably they will just make sure that you can just have the concept of a signed executable, and off you go. Because once you have the concept of a signed executable, it means that all Valve has to do is say, I want proof. There's this thing called attestation, right, which is also part of the SGX thing, which, to be honest, I didn't read yet, so I don't know what scheme they used for it. But there's a thing called attestation, which is a way that you can prove to the outside world that the thing you're running is an unmodified version of something else, right? So I don't actually know how the signing process works, but the answer is the reason that you can't intercept the public key and send some other public key that you want to come back, you know, something that you have the private key for, is because presumably if you actually decide to implement an Unbreakable DRM scheme, you will use attestation to make sure that everything on the machine is signed. And I'm not sure what they decided to do for that, because there's a whole chapter on it. Oops. There was a whole chapter on it, but I don't actually remember what they said. I wasn't paying very close attention because they were just like, well, we've got it. And I was like, all right, I trust you probably implemented it properly, but, you know. So let's see here. Where is the attestation section? Control structures, enclave signature structure. There it is. Okay. Let's see. Okay, so I think what they do, I'm not going to read this right now, but I'm just guessing based on what that said. So I think what they probably do is they sign that as well. So they sign the public keys themselves are signed with a key that only Intel has. So basically you can verify that Intel signed that public key, which means it's a public key that they have, not you. So basically again, making this up because I didn't go read the document very thoroughly, but basically what they do is they say, okay, you know, here's my CPU, here's the private key, right, and here's the public key. I'll give this one out. This public key is not just a raw public key. It's actually a signed public key in some way, which means that, for example, at Intel HQ, right, they have a private key and a public key, right? And they have used that private and public key to generate some attestation data that goes with the public key. So here's this public key, right? And what they do is they create a signature, right, of some kind, which anyone can, with the public key, can verify the signature, but only someone with the private key can generate the signature. And then you send this whole thing to Valve, and Valve can, you know, everyone has this, so Valve has it, they can go, is this public key actually a legal CPU public key? and Intel says yes it is, or Intel's public key, they use it to decrypt it, it says yes it is, and there you go. Right? So yeah, still unbreakable, and actually now that I think about it, that actually doesn't even involve any signing at all. Right? So that actually means you don't even need any of these to be signed. The Valve, the Steam client doesn't have to be signed. Windows can be completely exploited. It can be, whatever, and you still can't decrypt the game. Because the only way that you could decrypt the game is with the private key that's in here, because you can't send some other key because you don't have Intel signing keys. Does that make sense? Bathiumreth, what about the above scenario where there is no internet connection? How would one run such software in offline mode? This does not require an internet connection. The internet connection is only there for the time that you download the game. Once the game is downloaded, it is encrypted on your hard drive with your private key that's in your CPU. So you can always run the game on your CPU. It never has to go talk to Valve ever again. Right? Never again. So when it's on, once it's on your hard drive, you can play it anytime you want. The only thing you can't do is copy it to someone else's machine and expect it to run there. Because when you copy it to someone else's machine, that CPU has a different private key. It will try to decrypt the game with that private key, and it will just get garbage. Pseudonym 73, so the NSA doesn't have to crack it, they just have to rubber hose Intel. Yeah, you're correct, actually, yes, that's correct. So, yeah, the NSA and probably, other state actors potentially will probably just all get copies of that key, right? Because they'll, who knows? But the the American government can just go to Intel and just give us the key. We have an army. What are you going to do, right? So yeah, trust me, it is not breakable, right? Software-wise, not breakable. Hardware-wise, if you can get into here, then yeah, but no. Steve Void 1990, can't this be broken using emulation? Nope, can't be broken using emulation. And the reason it can't be broken using emulation, remember, so I'm just gonna go over the steps one more time. Step 1, send public key to, let's say Origin, let's say EA, say Electronic Arts Origin, right? Step 2, EA encrypts SimCity 12, right? Step 3, receive SimCity 12 encrypted and store on hard drive, right? Step 4, this is actually the part where you want to run the game. Step 4, CPU decrypts and runs using private key. Okay. So in step 1, when you send the public key to EA Origin, they know that not only is this public key valid because it's signed by them, but emulation, like you said, you're asking if emulation solves this. No, emulation doesn't solve it at all, because this public key can be verified by Origin as one that came from an actual Intel CPU. An emulated Intel CPU will have a public key, private key pair in it that Intel didn't sign. So they'll just say, no, I'm not sending you the game. So you never get the game, right? So that avenue of attack is gone. So you can't attack step 1. Step 2, EA encrypts SimCity 12. Well, if you could break into Electronic Arts, you could attack that. So hey, the DRM is breakable here in the sense that hackers who hack into EA could break it, right? But hey, that just means they got access to the original. So in this case, the DRM didn't fail. It's, it's social engineering and you broke into EA, right? But that's obviously neither here nor there. Obviously you break into EA, you could physically go break into EA and steal their hard drives, and then you've got every game that you want, right? So yeah, so that's not really breakable in any case that we're actually talking about in this context. Step 3, there's nothing to break because all you received is an encrypted executable. So you can't do anything with it. You can't copy it to someone else's machine. You can't inspect it. You can't do anything. It's a meaningless series of bits as far as you're concerned, right? And step 4, where the CPU decrypts and runs it, the SGX extensions ensure that no other process other than the one that's actually running can actually look at it. And since the process itself is actually being decrypted with that private key, no, you can't fake it and give it some other thing that's going to inspect the memory. So step 4 is not, none of these are attackable, right? And it doesn't matter if it's running an emulation, because if it's running an emulation, this will fail right here already. And so the only way you could ever get to here in emulation is if you'd already hardware hacked an Intel CPU and got a real private public key pair out of it. And that's why I said it's not software breakable. The only way to break it is through a hardware hack, which actually retrieves the private public key, right? Macielda, can't they just figure out Intel's key generator and make a key generator for it? Again, that's only if Intel is fantastically sloppy, right? I'm assuming that Intel's key generator is not predictable, right? I mean, if Intel really wanted to, they could collect neutrino hits in an underground lab and generate completely random data or something, right? Or they could have it hooked up to a seismograph or who knows what, right? They could actually generate completely really random stuff when they, that they feed into the fab, right? So who knows? So yeah, could they attack Intel's key generator? Only if Intel screws up. If Intel actually follows good practices for their key generator, it will never be able to be cracked unless someone hacks Intel. Steve Void, so even if the emulation contained a valid key from a registered copy, it couldn't be cracked. Okay, so again, I just want to underscore, there is no key with the registered copy. The game that comes down is encrypted, and it's encrypted using a key that's in your CPU, right? So it doesn't matter if you have a valid copy. Everyone's copy of the game will be different because each one will be encrypted with their CPU, and only their CPU will be able to run it. So there is no such thing as a registered copy of the game in that sense, meaning that there's some key in the game. The game contains no key. It was encrypted without putting anything on it or in it that identifies how to decrypt it. The decryption key is stored in your CPU and your CPU alone. And you cannot access it with any instructions because it's actually baked in the CPU. So the only thing you can do is hardware hack the CPU. You have to actually get out an electron microscope or something. I mean, I have no idea how you hardware hack a CPU, but you gotta use some kind of a hardware attack to get it out. But you can't do it in software. Andrew JDR, I assume this breaks certain features of the Windows API since the memory is protected. Global hook DLLs, for example. I don't think you would even probably be able to use these extensions until a future version of Windows enables them, is my assumption, actually, if that makes sense. So I feel like I saw a thing in there that says that you have to enable it when you start up in some CPU thing. So I don't know that, I guess the point is, I don't know that these will be usable in Windows that's not designed for it. So I'm assuming you'll have to wait for Windows 11 or whatever, and then it will have this enabled. So I'm assuming that they just take care of it, and when you run something in this, then yeah, those executables running under SGX will not have any of the other stuff that you would expect, like DLL injection won't run there, eJunkie64, what if the CPU fails or you want to upgrade? Again, it's not a problem for someone because they'll just relog into Steam and it'll re-download all their games, right? So, for most usage scenarios, it's just a little bit of time for that to happen, but otherwise it's fine. Long Boolean, would Intel create a different key for each manufactured CPU, or is there only ever one key? No, it's a different key for every CPU, and it has to be, because if every CPU had the same key, then you'd be right back to where we are now, and it would be trivial to circumvent, because my executable would be encrypted with the same key as your executable, as your CPU could read. So I'd give you the encrypted executable, and you'd be able to run it. So the only reason this scheme works is because each CPU has a different key. So when they go to launch an executable, they decrypt with different keys. So only things encrypted for a specific CPU will run on that CPU. That's crucial. Cracker door, but this means you lose control of your own system since only Intel can perform actions. Yeah, basically. I mean, thankfully, it's not required to have SGX, meaning you can still write code for a computer that doesn't have to be signed. For now. But yeah, so, you know, this is only for people who want to use the DRM. You won't have to get Intel's permission to run something on your CPU yet. You know, and hopefully that would never happen. Famous last words. How susceptible is the locking of portions of memory CPU cores to malicious encryption programs that simply want to screw your computer over? I don't think they'd probably not particularly problematic, because it's not privilege escalation at all. It's running in its own. It's running in its standard ring level. So the operating system can still just kill the task trivially, and you just can't see, you just can't get or access any of that memory, but you can kill a task that was running it, and the memory, you know, gets freed or whatever has to happen there, right? Happens, but you don't. It doesn't prevent you from terminating the execution. Ratchetfreak, if the game is sloppy and ends up allowing arbitrary user code execution, then the code can be leaked. I don't actually know about that part because I haven't read the SGX stuff carefully enough. It may be that the CPU will never execute any code that isn't encrypted with the key. So that might also prevent you from ever having arbitrary code execution, right? Pragma script, if anyone ever leaks Intel's private key SGX on all those CPUs would be exploited. Yes, correctly. Correct. So if anyone ever gets the Intel signing keys, it's not really the CPUs that would be exploitable, because the CPU isn't exploitable. The CPU is the thing that's providing the protection. So there's no exploit on the CPU. In fact, all this stuff is not a privilege escalation. That's the whole point. It's a user mode thing that prevents code execution without the correct key. So there's no exploit on the CPU, but if anyone leaks the Intel's signing certificates, right, the signing keys, then that means the DRM is going to be broken, because then that means the thing that someone suggested earlier, where you just send a separate public key that you have the private key to, you lie and say, this is the public key in my CPU. Now you can actually do that, because now you can make up a public key, sign it with the private key, and send it off, right? Popcorn09, why don't they use this system for banks? Something that's worth protecting? Well, banks probably will use this system now, right? Obviously, this system will have benefits, right? So you'll be able to get better security in other arenas because of this. The problem is it also means you're going to lose even more control over your computer than you already have, which is already quite a bit. Quartertron, can you think of awesome usages for this, like opt-in anti-cheat, so the server would know everyone on it had no aimbots or whatever? Yes, so basically like I was saying before, so the problem with this is basically that it takes control away from the user of the computer. Much like, you know, the constant thing of like, oh, you know, your government keeps you safe from terrorists, you just have to, you know, surrender all your freedoms or whatever. It's exactly that trade. So will you get things in return? Yes. Are they things you want in return? Are they worth it? No. I'm on the Ben Franklin side, like, you know, people who sacrifice freedom for safety deserve neither, or whatever he said. I'm on that side. It's like I don't feel like sacrificing the freedom to control what your machine does. Your machine should never be able to hide something from you. That's That's just a fundamental principle of computing that I will always stand by. I just do not like the fundamental concept is the user's in charge of the computer. As soon as you reverse that, I think you're in a world of hurt. And we're already halfway down that with the trusted platform module, and with SGS, it's now going to be times 10. So pretty soon, when you live in a world where nothing on your computer at all is under your control, you don't be surprised, because that's exactly what will happen. Because remember, corporations never want you to control anything, right? They never want you to be able to do anything other than exactly what they say. So the concept that this will be primarily used for your benefit is laughable. It will be primarily used for their benefit, and to the extent that that helps you, you will get helped, but that's about it. And so, yeah, corporations don't want viruses running on your machine for any particular reason unless they made the virus, right? So, yeah, that won't happen, right? But, you also will be very constrained with what, you are actually able to decide to save. You will not be able to back up software that you run anymore, ever. You will have to obey all of the things they want you to do to be able to run your software. When they tell you you have to upgrade now. Like full stop, right? Because they'll be able to completely dictate what it is you can and cannot do. RFH666, let's see. Will this constant decryption used while running a game have an effect on performance? I'm assuming not, but I don't know. Again, I haven't read the SGX stuff carefully enough to know. But I'm assuming they took care of that. So if it is a performance hit, I'm assuming it's a negligible one. Robbie, once a key pair is known, everybody could use it and encrypt the game with it through Valve, leaving Valve at encrypt everything with the same key for different users will fail on the way very fast. I'm not sure what you're saying. What do you mean once a key pair is known? But yes, if like I said, if you have the money to mount an actual hardware attack on a CPU, then you just have to try and convince Valve to buy every game on Steam or whatever before they catch on. And then you can decrypt them all, and then you can, post them to Pirate Bay or whatever, if that's your goal, right? So that could happen. But if they ever catch on, they'll just stop issuing for that CPU. So you can also imagine a scheme where Intel issues revoke certificates, where they're basically like, hey, everyone who uses our service, here's a big list of CPUs we've found that we no longer going to let people run code on, right? I mean, you could imagine a world, and this is a trivial imagination, just using the SGX code as it is, right? A world where they decide that you are an untrustworthy user, and now you can't run any software, commercial software at all. Because they sent to Adobe and to Microsoft and to Valve and EA and everyone else, they sent a list of certificate revokes, which basically say, all these CPU public keys, don't trust them anymore, and yours is on there. And now you can't buy anything. Your machine's a brick, effectively. And the only thing you can run is open source stuff. Right? Trivial, takes no effort to set that up. It's a trivial example of something that would be, not only would I say it's trivial, I guarantee you that's what will actually happen. There's no question in my mind. That's what they'll do. Cuber Caleb, re-downloading games sounds bad for SSDs. Not really, because, again, you never have to re-download the game unless you upgrade the CPU, which happens how often, right? Once in a very, very long time. Macielda, isn't it expensive for Intel to print a different circuit for each CPU? I don't know. I don't know enough about their fab technology, right? So I'm not sure. Pseudonym73, does SGX sound like a great place for a rootkit to hide or what? I guess? I don't know. Probably, yeah. Because I guess there's no reason it couldn't run at ring 0 as well. Like, I assume the SGX extensions just work. I don't know. Ratchetfreak, doesn't that also prevent jitting? No, because you could also, I'm assuming, because I looked and it looks like it's page-based, so your executable can also JIT stuff. That's, you can write to a region outside and even inside, so you can JIT to something inside and then run it if you want, right? But if you were actually allowing that, at least I assume you can do that, maybe you can't, I don't know. But at the very least, you could JIT to something outside. And then so the only thing that would leak is the JITted code, which you just have to make sure you keep that to a reasonable level so that that doesn't allow piracy, right? But it wouldn't, because all the data is not piratable. So you could just JIT to outside, and so people can copy the code. So what? They can't get any of the data, so the game's useless without the data, right? So you could still actually JIT a fair bit outside and be fine, outside the wall. Nascielda, isn't it expensive for Intel to print a different circuit for each CPU and maintain a queryable database for each client 24/7, considering its key was generated using a quantum measurement? Okay, so just to be clear, Intel does not have to maintain a queryable database. They in no way have to do that. None of this involves communication to Intel. And like I was saying, even if they want to do the nightmare scenario, which actually I think is probably a likely scenario, where Intel, or you know what, it doesn't even have to be Intel, now that I think about it. In fact, Intel doesn't have to do this, right? Anyone can maintain a blacklist of users now. There could just be a service called Evil Corporation Incorporated, and Electronic Arts and Ubisoft and Microsoft and Adobe and all those guys could just subscribe to their service, which is a blacklisting service, and that service just sends out which public keys are known to be pirates, right? And hey, if you happen to get on there, even if you weren't a pirate, you get on there by accident, tough. You can never get out, right? There's no way to, there's nothing you can do about it. So Intel could actually be a totally harmless actor in this scenario, but because they created the technology, a third party can now lock you out of your own computer, like basically making it so that you can't run any commercial software on it. Totally plausible scenario. I would actually say likely scenario. It's exactly like credit ratings are now, right? There'd be a thing called like Experian, and it would be like, is your software credit rating okay? Right? And if it's not, you can't buy anything anymore. You have to go purchase a new computer in order to be able to do so. It's ugly. Andrew JDR, have you heard any word on whether AMD will be implementing this? I have not. Huber Caleb, isn't DRM good if you want to prevent people from freely redistributing your software? So the problem with DRM is not that, it's not that software piracy isn't harmful to software developers, potentially, right? That's not the case, right? It's not that DRM is somehow not a useful thing for a software developer who wants to try and prevent any, who wants to absolutely maximize the profit that they get off something. DRM could be very valuable to that, right? The problem isn't that. The problem is the sacrifice. In order to get that, we give up control of our computers, and that's not acceptable, right? It's simply not acceptable. And so I've always been very against these sorts of concepts because I feel like if you make that trade, then you've lost essentially the spirit of computing. It's gone, and you can never get it back. So yeah, okay, maybe now instead of selling 100,000 copies of this game, you'll sell 150,000 copies of this game, or 200,000 copies of this game. Was that worth it? Right? Last I checked, games are making billions and billions of dollars a year. So to the extent that piracy is a problem, it's a problem of not making quite as much money as they were making, but not a case of all game developers are going out of business, right? So as far as I'm concerned, until the game industry basically collapses, it's really hard to make an argument that users should give up control of their own machines for the sake of us making 50% more profit. I mean, does that really sound like a good idea? Does it sound like a good trade for all the users of the world to give up the ability to control what their computers are doing so that game developers can make 50% more money? It's a recreational activity. Robbie, how you draw the future of restricted hardware? I should start not buying hardware like this, right? Yeah, the problem is, what are we going to do, right? This is the problem when you have monopoly on things. What are you going to do? Not buy a CPU? I mean, AMD will probably do the same thing, but even if they don't, Intel makes the majority of chips. So most laptops you buy, most desktops you buy, especially laptops, because you don't have the ability to build your own of those very easily. It's harder to do a good build your own laptop. Build your own desktop you can do easily, right? But it's like, it's pretty nasty, right? It's pretty nasty. SteveOid1990, I imagine this would be great for use for hardware banning from games. Yeah, maybe, maybe not. I mean, the thing that's kind of tricky about it is just that it's per hardware, not per user. So users can always get more hardware and then potentially circumvent it, right? But yeah, it does make it a lot stronger. It means a user can't create another account and now go do whatever it is they're doing. That they have to actually get a new machine. M4TTM53, as I'm still learning a lot, I always look at old code in my project and want to rethink the architecture of it. Oh, this is a separate question. Let me see if there's any more on the DRM Nightmare, since we're kind of getting that all into one stream here, which is good. Raw DGE, let's say a revoke certificate is issued for a compromised CPU and Valve et al. No longer issues new software. Why would your system be bricked? Since you already have an encrypted version of the software on your HD, how could they still prevent you from running the software that's already installed? They couldn't. So you can still run old stuff, but you will never be able to purchase anything new again, right? So it's not bricked in the sense that you can still run the games you already played. But you can't, but you couldn't get online with them, right? So that wouldn't work. And you certainly can't ever buy another game. So you'll never play another game after that, and you won't be able to play online anything. Nor will you be able to get updates to those games or DLC or anything else, right? Godfather, since the key is on the CPU, couldn't you just buy a new CPU if the key gets blacklisted instead of a whole new computer? Yes. You could buy a CPU and you could save the graphics card, right, which is the only other major expense of the computer. But the CPU is the big part of it, right? CPU is $400, whatever if you buy a nice one. I mean, heck, it could be $1,200 if you buy a really nice one. MMV94, won't that generate a huge market for computers that have been blacklisted? So you mean like people selling their old CPUs that have been blacklisted? Well, the problem too is now you've got this problem where if someone's selling a computer, you wouldn't know if it was blacklisted. So you'd have to somehow have an escrow where you could determine whether the CPU you were buying was blacklisted or not. It's going to be kind of a nightmare, but I bet it's going to happen. It feels like it is just a matter of time until someone somewhere breaks the scheme and it is just a massive waste of time and resources for everyone. Am I right? Well, best case scenario, you're right. Right? Best case scenario, yes, because that means now we don't have to live under that scheme, under that control scheme where other people are making our decisions for us about who can and can't buy software. Right? But, will it happen? I don't know. I have no idea. Ezio Audio Re-Revs. Isn't it DRM that is the primary driving force for piracy in the first place? I don't think so. In fact, I know it's not, right? Because I'm pretty sure The Witness was released with no DRM, and it got pirated a tremendous amount, apparently. So I don't think that DRM has much to do with piracy. Cuber Caleb, I think it is a bigger deal for companies like Adobe and Autodesk, both of which have software with insanely high piracy rates. Maybe, I don't know. MMV94, when big companies start locking out people from using their software, the people will start looking for software from smaller companies that won't use this technology. How are you going to do that? How are you going to not use Photoshop, right? It's already the case that you could go to a small software company for something, right? But they don't make anything that's comparable, you know? It's really hard to find alternatives. And plus, what will happen then? The big company will just buy that small company and then it's all over. That's what happens lots of times, right? It's like, you know, how many small things do you know of? Well, okay, Flash used to be a separate company owned by Adobe now, right? Like, a lot of things are acquired and sort of smushed up, right? Premiere was made by like in a college thesis or something. That's part of Adobe, right? I mean, things get accreted. They just buy a smaller company. So if it really created a problem, they just buy them. That's what Autodesk does. They own Maya, they own Softimage, they own 3D Studio, right? Like, you know, basically between the Foundry and Autodesk, there isn't a 3D package in existence that one of those two don't own, right? Hayai, do you think that there's a chance that the smallest trend of DRM free games will counteract this SGX stuff in any significant way? I have no idea. In my opinion, these things, we just shouldn't be doing them. Like, we shouldn't figure out what the future looks like when companies control what you can and cannot run, right? There has to be a balance there, you know, and I don't know. I mean, all I can say is that, like, how many people out there learn to paint in Photoshop on a pirated copy, right? And now they work at a company that actually legitimately pays for their Photoshop as an artist. Was that really that bad that that's what happened, you know? And I don't know, right? I don't know. And sometimes, yeah, I mean, there's, you know, sometimes companies do try to do things fairly and they have like a full-featured educational version of something or whatever, but, you know, I don't know. It really depends, I think, on whether how much you trust companies to do the right thing. And most of the time I find they don't, you know? Robbie, sad the entry costs and fab protections are so high, else I would find a Kickstarter soon to some fantastic user-owned CPU architecture. Yeah, it would be nice to have an open CPU architecture someday. Like, I think there's some people who started a competitor to ARM that's like an open source CPU architecture. Maybe someday we can just get on that and then forget all this stuff. But I don't know. The fab technology is really hard to come by, and you know, I don't know how that happens. Could this be taken a step further if they start putting the key on the motherboard instead of the CPU? That's less replaceable? No, I mean, the motherboard's often much cheaper than the CPU, actually. The CPU is often 2-3 times expensive as the motherboard. So putting on the motherboard doesn't really make it any worse. Andrew JDR, so apparently QEMU, a VM hypervisor, has support for emulating SGX. How is this useful? Well, I'm assuming, and I could be wrong, but I'm assuming that as long as you're running on an x64 processor with SGX, then it would just work, right? Because the emulated processor would just use the actual processor's public and private key. And if you didn't want to do that, you could make up your own public and private key and still run just fine. You wouldn't be able to actually, you wouldn't be able to attest to anyone outside that you were a legitimate Intel CPU, but that may be fine too, right? Maybe you're not trying to do that. So the SGS extensions for security would still just totally work under emulation. And if it's an actual x64 processor with SGX that's running it, they would actually work for attestation as well, because all the VMs would all attest as that processor correctly. Soy Sauce the Kid, for businesses, wouldn't this tech be good for the consumer? I would feel more comfortable if my bank had my encrypted data as tight as possible. So the problem is, I don't know that this helps banks really all that much beyond the current, though, because as long as some customer service personnel can access your account, then hackers can, right? The fact that SGX is keeping like some process from accessing it potentially doesn't necessarily help you, because they won't attack, hackers won't attack that point. They'll attack the customer service gateway or something, right? So I don't really know how useful this is for a bank. It adds a little bit of security potentially from virus attacks on the bank, maybe, or something like that, maybe. But I don't know that it really prevents hack soaring, assuming that the bank has remote customer service of some kind, or even local customer service for that matter. We only got 1 minute left, so I'm going to see if there's anything else. Cuberkillab, has Rad ever had problems with people pirating their software or people releasing the source code? Yes, they have. And, you know, they deal with it on a case-by-case basis. Macielda, could encrypting each 16 gigabyte game download using your SGX key be prohibitive cost for a company like Valve? How likely would it be for Valve to refuse doing such a thing? So Valve, you know, has a mixed record, I would say, as far as ethics, in that they're not like EA, which is strictly like seems to have only their best interest in mind. Like Valve does occasionally do things that I feel like are not so great, but oftentimes they do things that are pretty ethical or pretty fair to the consumer. I feel like Valve does. So it's entirely possible that like Valve might not do this, right? You know, they might decide that this is too dangerous a route and they don't want to do it. So I don't think they would be patient zero. Like EA's Origin service, for example, would probably be the much more likely one to like adopt this sort of thing first, I would say. As for whether encrypting the game download being prohibitive, it's not prohibitive at all. The cost of encrypting the bytes of something is so cheap that it's the bandwidth cost that's expensive. Having the CPU as it shovels something out the network port, apply encryption to it is practically free. Robbie, I am less afraid of price control with DRM strong as this one. I'm more afraid that the OS of the future will block software that hasn't been signed. That is scary. Yes, and you should be very afraid of that, because that almost certainly will happen. I mean, it sort of already is happening on the iOS, right? Like, you can't run software on your own iPhone without signing it. Full stop. And so I think that sort of thing will only get more prevalent. And yes, I am very much against that, and I think it's a huge problem. Very, very bad. Avalier, would the entire time need to be encrypted, or just the executable part? I mean, basically, the part that you don't want to be pirated has to be encrypted. So if you don't mind all the art getting pirated, but you just want to have the executable not get pirated, then yes, you could just encrypt the executable. So it depends. Probably for most games, it's sufficient to just encrypt the executable. You probably don't need to encrypt the art. Because if they can't have the executable, what are they going to do? Re-implement the whole game? Probably not, right? So it's probably sufficient to leave the art unencrypted. Godfather, since Valve made a big push for Linux, I'm willing to bet that they won't jump on the SGX train since it is a possible limit to consumers. SGX works on Linux just as well as it will work on Windows. It's a CPU thing. So, Huber Caleb, what is code signing anyway? Code signing is, again, just exactly the same thing as what I was talking about here with the keys. So basically, it's like this sort of thing, where there's some concept of a certificate that you use to sign something, so that it can prove that it's valid. So I'll give you an example of what that is. All right. All right, so the basic idea of public key encryption, I already said what it was, right? The idea is that you generate a pair of keys, a public key and a private key. And you give this one out to everyone. This goes out to the world. And this one is a secret, and no one else knows it but you. Okay? That's how that works. And what public key encryption allows you to do is basically, depending on how the scheme is set up, it allows you to pass data in either direction here, such that you can, for example, encrypt something this direction, meaning I can encrypt something with the private key, and then everyone with the public key could decrypt it and know that I was the only person who could have encrypted it, right? Because I'm the only person with this. Or you can go the other direction, which is to say that I can encrypt something with a public key and know that only people with the private key can decrypt it, right? So what you were asking, what code signing is a thing that goes in this direction, right? If I'm Apple, I retain this secret key that all iOS devices have a public key baked into them that is the pair for it, but only Apple has the private key, let's say. So you submit an executable to Apple, right? They encrypt it with the private key, or in this case, they probably don't encrypt it. They just sign it, which means they take like a checksum of it or something, and then just encrypt the checksum. So they don't need to encrypt the whole executable because they're not trying to protect the executable. They're trying to just prevent it from running, right? So they just encrypt some measure, some approximation, like a hash or a checksum, let's say. But if we wanted to be paranoid, we could encrypt the whole thing. So let's just say we did that. We encrypt the whole executable with a private key, right? And now all the iOS devices all have the public key on them already, and everyone has that, so it's fine. And so when they go to run something, they only run things they can decrypt with the public key. So they decrypt and run. So obviously, since no one else has the private key, no one else can actually take an executable and produce something that, when decrypted with this public key, actually produces a working executable, right? Because if you took some other private key and feed in the executable, encrypt the executable with that, and feed it into here, you'll just get garbage out, right? It won't look anything like the executable you put in. You'll just get a completely meaningless bit stream. So that's what code signing is. It's the operating system having a public key and the vendor having a private key, such that only people who pass their executable through the vendor for signing can actually run on the end device. Masielda, Casey, would you consider prioritizing developing for OSs which refuse to use SGX? I mean, sure, but I doubt any will. If that makes sense. Steve Voigt, you should do more streams about this kind of stuff. It's really interesting. When it comes up, I mean, like I said, since we're on RSI break, we might as well chat about everything. Robbie, DRM like this is sad. Can you please choose a happier topic for the next chat? I can try, but unfortunately, this doesn't go away. If that makes sense. All right, so I think we're pretty much done. Anyway, we're out of time here on the stream, so I'm gonna wrap things up. That was Unbreakable DRM in a nutshell. Sad but true, coming down the pipe, and probably not gonna be stoppable. Yeah. What are you gonna do? If only people were nice and actually cared about like progress and happiness and things instead of money. Wouldn't it be great? But that's not the world we live in, so oh well. Anyway, thank you very much for joining me for another episode of Handmade Hero Chat. We will probably be back next week for some more chat. Until then, I hope you guys have fun programming. I'm sorry that DRM will ruin all of our lives eventually. That's just the way it goes. Maybe we'll be able to do something to stop it. Who knows? But for now, that's just the sad state of affairs. Yeah, so go ahead and everyone go cry on your keyboards. I will as well, and maybe our collective tears will short out the world, and it'll be some kind of grand protest. Thanks for joining me, everyone. I will see you back here next week. Don't forget to check the tweet bot on handmadehero.org to find out what the schedule is. Until then, have fun coding, and I will see you guys on the internet.